Hello, Algebra 2 students. Today we're going to talk about solving systems of equations by substitution. Now you already know there's 4 ways to solve systems of equations. There's graphing, which we already did. That's where you graph the two lines and you find where they intersect. Then there's substitution. That's the one we're going to do today. Another one that we'll do next is elimination. That's next time. And then the fourth one is matrices, and we'll do that in the next unit. So today we're going to focus on solving by substitution. Alright, you've been doing substitution since pre-algebra. For example, here's a substitution problem. Evaluate this expression, 2x plus 4, for x equals 6. You've been doing this since pre-algebra. The first thing you do is you got the original expression. You substitute the value, because if x is equal to 6, then you can plug in 6 for x. You simplify and you get your answer. So you've been doing substitution since pre-algebra. The difference is, instead of plugging in numbers, you're going to be plugging in whole expressions into other expressions. Alright, let's take the first equation right here. So we have these two equations. This is a system of equations. One way to solve this is by graphing. We could graph it and find where the two lines intersect, but today we're going to be solving algebraically. So we're going to take y. Since y is equal to this expression right here, we're going to take this expression and plug it in for y. So instead of writing y in this equation, we're going to replace it with this expression. So we're going to have 2x minus 3, and instead of y, we're going to replace it with negative x minus 12, because negative x minus 12 is equal to y, so it can be substituted for y in the other equation. Alright, we're going to simplify this. We have negative 2x plus 3x, because you have a negative 3 times a negative x, and then plus 36, because we have a negative 3 times negative 12, equals 6. Now, what was the point of this? Why do we even need to do this? Because we used to have an equation with 2 variables which can't be solved, and another equation with 2 variables that can't be solved. But you can solve an equation if it has 1 variable. We can isolate x in this case. So we've got 5x plus 36 equals 6. This is just your basic algebra. Okay, subtract 36 from both sides, and that so that you can isolate the x. So subtract 36, that cancels out. So we have 5x equals negative 30. Divide both sides by 5, and you get x equals negative 6. All right, but we're not done yet. That's just the value of x. We have to find the value of y as well. So we're going to take this solution and plug it back into one of the 2 equations to get the y value. You can use either one. With substitution, if one of the equations is solved for a variable, it's usually easiest to plug it into that one. So that's the one we're going to plug it into. I'm going to take this and plug it in now into this x. So I have y equals negative x minus 12, but I'm going to replace the x with negative 6, because we just solved for x and got negative 6. I'm going to simplify that expression now. Negative 6 would be positive 6 minus 12, so y equals negative 6 as well. Now usually they don't come out the same. This particular problem, they did come out the same. Alright, so now we need to write the solution, and the solution is typically written as an ordered pair in parentheses. We have negative 6, negative 6. Alright, now if you were to graph these two graphs, you would find that they would intersect at the point negative 6, 6. So that's your solution. Alright, let's go on to another example. Now in this one, one of your equations is not solved for y. So the first thing you have to do is get one of the equations to equal a single letter, a single variable. So I'm going to take the first one and I'm going to solve this equation for y, since it's easiest to solve for y. Okay, so I'm going to take 3x minus y equals 0. To solve for y, the easiest way to do this would probably be to add y to both sides. So I'm going to add y to both sides, because that will allow me to get y by itself and positive y by itself. So 3x equals y, or in other words, y equals 3x. Now I'm going to take that expression and I'm going to plug 3x in place of y in the other equation. Now you can't plug it back into the same equation you just used, or it doesn't help you. So you need to plug it back into the second equation. So we're going to have 4x plus 3 times equals 26. Now we're going to substitute in the 3x in place of the y. oops, excuse me, that should be an x, 3x in place of the y. What was the purpose of this? Well, we've turned this equation, which has an x and a y, which can't be solved for either x or y and get a number, to a one-variable equation that can be solved for this one variable. Okay, I'm going to simplify this and solve this. 3 times 3 is 9, so that's 9x equals 26. 4x plus 9x is 13x equals 26. And you can do this mentally. Divide both sides by 13 and you get x equals 2. All right, now we're not done. We still have to take this partial solution, plug it back into one of the two equations. It doesn't matter which one you plug it into. You can plug it into the first one or the second one. I'm just going to plug it into the first one for x. So I'm going to take my first equation, 3x minus y equals 0, and I'm going to substitute in place of the x the value I just solved for. Just got 2 for x. And then I'm going to simplify. Now look, again, I went from a two-variable equation to a one-variable equation. This only has a y. All right, so we have 6 minus y equals 0. If I subtract 6 from both sides, I'd have negative 6 equals, or negative y equals negative 6. And if negative y equals negative 6, then positive y equals positive 6. So now I have my x value and I have my y value, and all I have to do is put them together in an ordered pair as the solution. So the solution to this system of equations is the ordered pair 2, 6. Now that means that 2 is the x and 6 is the y. It has to go x, y. It is important the order that you put it in. The x has to come first and the 6 has to come second. So there's your solution. All right, let's do another one. This one, you don't have to have it solved for y. You can have it solved for x. So this one right here, since it's solved for x, I'm going to take this expression, plug it in for x. All right, let's go with that. So we have negative 2. Instead of x, I am going to be plugging in this expression that involves y. That way I can turn this two-variable equation right here, this two-variable equation turns into a one-variable equation because it only has y's. All right, simplify and solve. So that's negative 24 plus 6y plus 4y equals 9. Add your like terms, negative 24 plus 10y equals 9. We're going to add 24 to the other side. So 9 plus 24 is 33. Okay, and divide both sides by 10. Now when you divide by 10, 33 divided by 10, that can't be simplified and it's not a whole number. I'm going to write it as a decimal just because the decimal is going to be easier to plug in, but you can also write it as a fraction. Okay, I'm going to take this value and I'm going to take that and plug it back in for y. You can plug it back in for either one. Once you solve it, you can plug it back into either one to get the other value. I'm just going to use the first one. So x equals 12 minus 3y, that's the original equation. In place of y, I'm going to substitute the value I just found, which is 3.3. And then I'm going to simplify. So 12 minus, this would be 9.9. And 12 minus 9.9 would be 2.1. Okay, my final step, the final step in writing the solution, it's not just x and it's not just y, it's both of them. You have two variables with two equations and you're solving for both variables. So there's your solution. And see, this is a situation where you wouldn't want to graph these and solve by graphing because they don't actually cross at integer points. They cross at decimals. There would be no way to really graph accurately enough to see the intersection point and have it be perfectly solved. That's why you need algebra sometimes. Okay, this last one, this is a special case. You might be saying, well, it looks the same as the others. I'll show you why. Okay, since y is equal to this, you're going to substitute it in place of y right here. So the original equation, 12x minus 4, but in place of y, I'm going to substitute in the expression that is equivalent to y. So 8 plus 3x. Now I have an equation that has only x, so I'm going to simplify and solve. 4 times 8, that's negative 32. Negative 4 times 3, that's negative 12x. And that would be 15. Oh, look at this. 12x minus 12x. What happens to those? 12x minus 12x cancels out. So what do you do with that? all that's left over here is negative 32. All that's left over here is positive 15. No x's. Is this true or false? It is false. So this would have no solution. There's two different types. If you have an equation that ends up the variable cancels out and it's false, okay? Variable cancels out and it's false. All right. If it's false, then that means it's no solution. If it's a true equation when the variable cancels out, then it's infinitely many solutions. All right, those are the two special cases, infinitely many. All right, let's go to the final slide here. When is substitution best? Well, if we think about all the different ways to solve systems, graphing is easy if you already have your graph paper and if the equations are set up in graphing easily to be graphed form and you know they're going to come out as whole numbers. Graphing is good. It's also good for checking your solutions to see if your solutions are reasonable. But substitution is a good algebraic way if at least one equation is solved for a variable. So let's look at these two. Which one of these would be better to solve with substitution? This one right here. The reason why this one would be better to solve with substitution is because you have a single variable equals an expression. And that's always easiest because then all you do is take this expression, plug it in, and go from there. This one, if you wanted to solve by substitution, you would have to solve for x or solve for y in one of the two equations. There's a way to do this kind. You can solve it by substitution, but you'll probably get fractions. There's a way to do that. It's called elimination. We'll do that next time. But for now, substitution is best when it's in this form. All right, hope that helped. See you next time.